And this tutorial is about the introduction to the Arduino, and this is the series of tutorials. If you people like this, hopefully I'll make another tutorial. So this is just the introduction of Arduino and overview of how it works. And so the first question that comes up in our mind is that what is Arduino? Well, it's an input and output microcontroller board which can be programmed to do certain tasks. We have a lot of tasks in our daily life that works using microcontroller. We will study more and more in depth in the coming lessons and the slides. So it can read sensor values and send values to the actuators to do respective tasks. So it can take the sensor's input, it can read the sensors and use the actuators to do certain tasks. For example, actuators like motors and different components. So we can connect Arduino with the sensors and actuators using the connecting wires. So this is wires are used to connect, because you can see that Arduino have the pins. So these pins uses the wires to send the signals and receive the signal. So we'll learn more in depth. So let's learn about sensors. The sensor is something that can sense the attributes of the daily life. For example, we have the eye converts light into the signal that can be sent to the brain using the nerves in our body system that we can easily understand. In the electronic world, we can see the LDR, also called the light dependent resistors, that can measure the amount of light that hits it and reports it as a signal that can be understood by the microcontroller. So the signal from LDR can be sent to the microcontroller using wires. We will learn how the connection will be done, but this is just an overview. Other example includes the temperature sensors to sense the temperature of the environment. We have a lot of temperature sensing sensors. The fire sensor, we also have the fire sensors to sense the presence of fire. The proximity sensor to sense the presence of anything nearby, or and so on. Talking about the sensors, we have put a lot of sensors here to let you know that we have different kind of sensors. This is the temperature sensors, also called the DHT11. This is the moisture sensor. This is the proximity sensor. This is the sonars or ultrasonic sensors. So every sensor have different functionality. This is the water level sensor. This is the relay. This is like ESP32. It connects with the Wi-Fi to do certain tasks using the Wi-Fi. So it can go deep and more in depth because this is the C technology that you when you go into this, and you will learn more and more and you'll enjoy. So this is the LDR. You can see this is the microphone. This is the this is used for the tone. So let's talk more about the actuators. We learned that there are sensors to send the signal from to sense the environment parameters like temperature and other things. And what if we want to react to the environment? We have, like, once the sensor have been read, the Arduino had the information needed to decide how to react. So the decision making process is handled by the microcontroller and the reaction is performed by the actuator. We can give an example of our body. Muscles receive electric signals from the brain and convert them into the movement. And in electronic world, these responsive functions could be performed by an actuator using motors, buzzers, and light bulbs. This is our daily life example. So let's talk about the Arduino and try to understand what is this. So it's kind of a philosophy that is based on making designs rather than talking about them. So we make a lot of prototypes, designs, and the projects using this Arduinos. It's a constant search for faster, more powerful ways to build better prototypes. So it includes two parts, hardware and software. And let's learn about hardware and software. First, we talk about the hardware. So the Arduino pins, as we can see, there are a lot of pins here. So these pins are inputs and output pins. These pins are for sending and receiving signals, as we talked about before. Using these pins, using these slots, you can see these are the holes where the wires can be connected, and these pins can be connected to these sensors and actuators using wires. So we have 0, 1, 2 up to 13. These are like the digital pin, as you can see here. These are the digital pins. 0 and 1 is normally used for TX and RX. Right now you don't know about the TX and RX. Let's leave it right now. And we can use a 2 digital pin up to 13 digital pin. And we have an analog signals as well. There are two types of the signals: digital signals and the analog signals. um, in the coming slides I'll talk more about that. So 14 input and output pins and 6 in and output analog pins. So there are 14 digital input and output pins. So Arduino input and output pins operate at 5 volts, and USB can be connected here, power port. So there are 3 ways to give the power using the USB connectors, the power port, um, and you know here we in and ground. So we can give the input of the power source here, so it can be powered on. So let's talk more about the Arduino shield as well. Like, we have a lot of shields. Let's talk right now about the sensor, Arduino sensor kit. It got a lot of sensors inside it, which is the benefit that you don't have to use these sensors from outside. So different shields we have. So there are actuators and sensors inside it, and we mount an Arduino on it and access all the components without connecting external using wires. We have a bunch of wires here as well with this kit, and it's quite useful as well. So what do we have in this sensor kit base? We have an LED, buzzer, push button, potentiometer, and the light sensor. This is the light sensor, and the sound sensor, air pressure sensor, temperature sensor. This one is temperature sensor. Accelerometer, acceleration we measure from it, and OLED screen. So it's quite useful, as well as we can connect it directly to our boards. So let's talk about the software as well. So what do we have in softwares? We have a lot of softwares to use, but I'll list down only 3 of them, because it's quite it's quite a long time I've been using these 3 as well, and these are really easy to use softwares and very open source. So Arduino IDE is one of them. Mixly, the mostly uses Arduino IDE. Mixly is also used. Tinkercad is the platform that you can access, or like you can program everything using online. Um, so uh, you know is used to Arduino IDE is used to write down like C and C++ program. If you already know about the C++ program, it's super easy for you to uh, do some programming in it. Mixly is used to write programs using function blocks. We also have an option of writing the code of C and C++ in Mixly, but mostly it's used for the block diagrams. In the same way, Tinkercad is used to write down programs using function blocks, but we have also have an option of writing C or C++ program. So platforms like Portentide 7 and Ping Pong boards use Python as well as a language, uh, but it's still developing right now. It's new comparatively. So in this lesson, we won't talk about that. Uh, let's learn about like how Arduino. How can you get an Arduino IDE? Just go to the website and you'll find out. So, uh, uh, and talking about the Mixly, we can find out the Mixly and download it from here. It's causing a problem in MacBook, iOS system, but it's pretty easy to install or download in Windows. So we can take, we can get it easily. Tinkercad is the online platform. Let's go to the website and try to learn like how does it. So you can log in and like try to use it here, and uh, let's go further. Talking about the Arduino IDE, we have a what do we have is that as soon as we write down the program here, sorry, as soon as we write down the program here, you can see that we have the two functions, the setup functions and the loop function, which is going to exist always whenever you try to write down the Arduino IDE program and upload it onto your microcontroller or onto your Arduino. So sorry. So we have the verify, upload, verify to check the syntax of the program. Upload is to upload it onto onto the microcontroller, and the new file, new is for the new file, to create a new file and try to write down your own code. And open is to open a Arduino file which you may already have, and you try to just upload onto your microcontroller and save is for save. So talking about the Mixly, we have this kind of an overview that it includes a lot of blocks, and you choose the block based on your logic, whatever logic you want to create. You will have the input and output blocks, control blocks. Control blocks include like the if and else conditions and all that. It's super easy that if you go through that, you'll know easily within 5 minutes, like you will be able to learn how to code that. Math is for like you'll go more deep and you'll know about like the code blocks, and we have the compile code to check the syntax just like we have in Arduino IDE. And we have an upload code to Arduino board. We can choose what board do we have right now and the port as well. And we can check the input and output outputs using a serial monitor. You probably already know about the serial monitor. If you don't know, you can know easily, don't worry. And what do we have in Tinkercad? We have the option of using only blocks or only code, and we can write down the code on the right side. Right now we have selected on both the blocks and the C++ code, so right now we can watch both of these codes. And On the left side, we can see that we have the microcontroller, and we can burn, or we can upload our code onto that microcontroller, and we can see the outputs. You can see we have the simulation. We can see um, the start simulation on the right top, and we can start the simulation. So once you try, you'll know really easily like what you have to do. You can just open some examples, and you can just upload it over there, and you'll know how to do it. So Mixly Blink program, the first program, whenever you try to learn Arduino, it is recommended to do the Blink program. So the task is that we have an internal LED into the microcontroller that is attached directly to the digital pin 13, and we'll make simple flow chart for this, and we'll turn on and off the LED after 1 second. Flow chart, let's learn about the flow charts. You probably know about the flow charts before, but if you don't know, you can know from this slide as well, because starting from the top, we have the digital write high logic on the pin 30. As we know that we have the digital and analog signals. Digital signals can only be high or low, uh, or 1 or 0, so we'll write down a high logic on the pin 13, which is internally connected to the internal LED. So wait for 1 second, and after that, like, turn off the LED at pin 13 by digital writing low, and wait for 1 more second, and then end our logic. As you can see that we can see here the Blink program. We wrote down the logic here directly, that you can understand. We need to give 13 pin digital signal to turn and off, on and off internal LED connect pin 30. So we wrote down a high logic, and then wait for 1 second, and we gave low logic, and then wait for 1 more second. As we can see that the colors, the green color shows the green blocks on the left side, and the brown color of the block, which is the digital write, you can see on the left side that it can be found on input and output blocks. And this one, you can see this. So as soon as you give logic 1, it's going to turn off, turn on, turn off, turn on. You can see this simulation to understand more and more. And what about the external LED? If you want to connect anything externally and try to give the signal to it, you can do it really quickly. We'll use any digital pin of Arduino. Let's say the pin 10 we use, and we give the logic 5 to turn it on and off. And we use the resistors, and resistor and LED diode, and the jumper wires to connect these, connect this circuit. So this is going to give the signal to the LED. You can see the LED, this pin is a bit longer, which is gonna be the positive pin. You always give the pin, the signal to the positive, uh, positive side of an LED, and the negative side is always connected to the ground. So this is grounded using the resistor. It depends on you what resistor are you going to use. Like, we have plenty of resistors: 1 kilo ohm, 220 ohm, and the lesser the ohms, the resistance is going to be, the more, the brighter the LED is going to be. So you choose it depending on that. And this is the Mixley code for to write down the pin 10, that we give the pin 10 a high and low for 1 second, just like we did for the pin 13. Or let's talk about the Tinkercad as well. We would write down the same code to turn on and off the, you know, externally an LED. So what we wrote down here is that we set the built-in LED. We have an option of built-in LED, which is the LED connected to the pin 13 internally. This is an LED, and we gave the high logic and then waited for 1 second, and then gave low logic and waited for one more second. So this is the same logic as we have implemented before. And let's make it short. We write down the Arduino IDE as well. We wrote down the same C++ program as we wrote down the Tinkercad as well. You can see this one. You can just copy and paste over there in Arduino IDE and implement it the same way, and you'll find the same results. So I just gave a little bit demonstration of how it's connected, you know. So it's right down, turning on, you know, an LED is connected to the pin 10, and this one is the ground. So we can use any ground. Let's say we can use this ground as well. We have 3 grounds in Arduino Uno. So we are turning on and off for 1 second. So thanks a lot for taking this tutorial, and if you wish, if you want me to make more videos, this is just a startup. I'll talk more in details. If you want, just give me your feedback, and based on that I'll make more videos. Thanks a lot.